Alrighty, geometry crew, how are we doing today? Today we are going to be talking about triangle inequality theorem. I'm going to write it up here. Triangle inequality theorem. So let's start off by looking at, let's say we've got three lines here. Say we wanted to try and make a triangle using these three lines. One has a length of 5 inches, next one's 3 inches, next one's 1 inch, as you can see here. So let's just say we wanted to take this side, we're going to turn it. We'll use this long side as our base. We lay that down. Remember, that's 5 inches. We bring this other one over, rotate it. We'll throw that one on this vertex here. Now, let's take a look. Okay, well, what happens when we bring over our other side? Well, if you notice, no matter how we rotate this, we are never going to be able to, even if we lay them almost exactly flat next to each other, it will never be able to reach that other side. Okay, so even if we keep turning and turning and turning, we know that we aren't going to be able to make a triangle. Why? Because this 1 and 3 won't add up. Even if we lay them flat right on top of each other, this 1 distance plus this 3 distance will never be the length of this 5 distance. Okay, so let's say, okay, let's look at another little example here. Let's keep this first side 5 inches, and this other side is now 4 and 2. And we'll just try and do the same thing. Well, let's try and make a triangle here. Well, okay, we'll use this as our base. So we've got it here. All right. We can turn that any way we want, but we'll leave it like that as with our base. And again, we'll put that 4 in this spot here, rotating it. Put that right on that vertex. And let's see if we can make a triangle with this 5, 4, and 2. So if we turn this here, okay. Well, if you notice, now it looks like these are going to be able to match up. And we can actually make, with enough trial and error here, we can make a triangle just like so, using 5, 4, and 2. Well, what do you notice? Oh, well, what's 4 plus 2? 4 plus 2 is 6, which is greater than 5. Oh, well, what happens on the other one? Oh, 3 plus 1, that's 4, which is less than 5, which brings us to our triangle inequality theorem. So let's jump over to our guided notes page, talk a little bit more about this. Okay. So we'll start here, triangle inequality theorem. First things first, our conclusion for our triangle inequality theorem is that for any 3 legs of the triangle, the sum of the 2 short legs, some of the 2 shorter legs, has got to be greater than the long leg. So let's go back through that again. For any triangle like we had with our 5, 3, 1, 3 plus 1 was 4. The 2 shorter legs, 3 plus 1 was 4. That does not equal to greater than 5, so we cannot create a triangle. But when we did 4 and 2, 4 plus 2 is greater than 5. So we know we can make a triangle with 5, 4, and 2. So let's say, given these three legs of the triangle, all right, first thing we need to do is we need to identify the two short legs. Okay. Well, our two short legs are going to be the 18 and the 10. So second thing we're going to do is add them together. Okay, well, 18 or 10 plus 18 is 28. So then if that is greater, if the sum is greater than the third leg, then we can make a triangle. And the third side, we have a triangle. So, for example, 10 plus 18 is 28. 28 is greater than 20, so it is a good triangle. So if we keep moving here, can you construct a triangle with the legs given? Explain why or why not. Well, okay, let's do the same that we did here. Let's find our two shorter legs. Okay, 3 and 5. We would say, oh, 3 plus 5 is equal to 8. 8 is less than 10. Our third side is 10. So since that is less than the third leg, we cannot have a triangle. Why can we not have a triangle? First off, we cannot make a triangle here because 8 is less than 10. That sum of these two sides is less than the third side. So let's look at B. Okay, 11, 9, and 4. We have 4, we have 9. 9 plus 4 equals 13. We need that to be greater than, is 13? Yes, it is greater than 11. So yes, we can make a triangle here. Why? Because the sum of the two short legs is greater than the third. So here we said 5, 4, and 2. We already looked at a triangle like this in our previous examples, but just for the sake of it, 4 plus 2 is 6. We know 6 is greater than our other length, which is 5, so we can make a triangle here. Ooh, now this one's going to be tricky. Moving on to D. Here's our two shorts, 3 and 5. These are two shorter legs. 3 plus 5 is 8. Well, 8 does equal 8, but we need it to be greater than, not greater than or equal to. So we cannot make a triangle here. Cannot. If they are equal, if the sum of the two shorters is equal to the longer, we cannot make a triangle. Okay. Moral of the story, find your two shorter side lengths, sum them together, make sure it's longer and not equal to or less than that third side. Okay, so let's scroll down. Let's look at this last part here. Given the two side lengths, what must be the length of our third side? Well, we know that our two shorter lengths added together has to be greater than this value. So we know that if this has to be greater, then we can just, for the minimum, we can find whatever the difference is between here. And we could say, okay, well, it's got to be our long side minus the shorter side. Would it be 8 minus 6 in our case, which is equal to 2. So our minimum length would have to be at least greater than 2. And what's the maximum it could be without going over? Well, the max it could be would be the sum of these two. So the max would be that longer plus the shorter. 8 plus 6, which would be 14. So in conclusion, we have to be between 2 and 14. But we can't be exactly 2 or 14 because 6 plus 2 would be exactly 8, and 6 plus 8 would be exactly 14. So that means that we have to be between them and not exactly on them. So if we wrote it in interval notation, it would be x has to be greater than 2 and less than 14. But remember, it cannot be exactly 2 or 14. Okay. So a little bit similar here in example 2. Two sides of a triangle have the following measures. Find the range of that third side. So here, if we have 31 and 35, if we just find that difference between the longer and the shorter, 35 minus 31 is 4. There's your minimum. Maximum it could be is we add them together. 35 plus 31 is 66. So in conclusion, x has to be between 4 and 66. Big thing here. Remember, we have just less than here, meaning it does not equal. We cannot be equal to those measures. It has to be in between those measures. So again, we have 24 and 12. 24, we take our finding the difference. 24 minus 12. So our minimum is 12. For the max, we can add them together, thinking that these two would be the shorter side. That is 36. So in conclusion, we have to be between 12 and 36. Okay, and finally, one more example here. To find the minimum, this would be that's saying 90 is our longest side. 90 minus 50 is 40. And then if assuming these two were our shorter sides and we need the longest side, we can find the max by doing 90 plus 50, which is 140. Conclusion, it has to be between 40 and 140. Pretty straightforward there. Moral of the story. Oops, sorry, 140. Moral of the story with our triangle inequality theorem is the two shorter sides added together must be just greater than that third side. Okay, so that's all we have. Go ahead and work on the rest of these exercises on your own. It will be posted on Canvas, as well as handed out to you in class. This will be posted, the video will be posted on Canvas along with these exercises. If you have any questions, please let your teacher know. Send them an email, and we can get that figured out. Have a great day, guys.